Welcome back to The Explainer. As academic biologists deeply fascinated by evolutionary human physiology, we're absolutely thrilled to dive into today's topic. We're going to take a really strict, advanced biological look at how a highly specific, very brief mechanical action can radically alter human postprandial metabolic pathways. Seriously, we're looking entirely at the science of what happens inside your cells right after you eat and how a simple physical intervention can literally bypass a failing insulin system. Let's get right into it.
Here is our rapid-fire agenda for today. We'll start with postprandial glucose pathways, followed by the consequences of chronic hyperinsulinemia, skeletal muscle contraction mechanics, the GLUT4 translocation mechanism, physiological parameters of activation, and we will wrap up with clinical contraindications and thresholds.
All right, let's jump right into Section 1, postprandial glucose pathways, the biological baseline.
So what exactly is postprandial glucose metabolism? Well, fundamentally, it's how your body processes ingested carbohydrates into circulating blood glucose. When you eat carbs, say bread, rice, or fruit, your intestine rigorously breaks down those complex structures into simple glucose. And boom, this glucose rapidly floods your bloodstream. In a perfectly optimized biological state, this sudden influx forces an immediate, precise endocrinological response from your pancreas to handle all that circulating fuel.
Think of this process like a rigid, almost unforgiving ticking clock. At minute 0, you ingest the nutrients. Just 15 to 30 minutes later, we see the initial rise in circulating blood glucose. And then, between 60 and 90 minutes post-ingestion, we hit the absolute peak glycemic spike. It's an incredibly narrow window. What you physically do within these specific minutes pretty much entirely dictates your metabolic trajectory for the next several hours.
Which brings us to Section 2. Chronic hyperinsulinemia consequences and age-related cellular resistance.
Okay, so picture functional insulin sensitivity like a perfectly cut master key. It smoothly unlocks your cellular doors, allowing glucose to slip inside and be burned for energy. But as we age or with chronic sedentary behavior, we run into age-related insulin resistance. Those cellular locks get functionally hardened. They become oxidized. The insulin key simply stops working efficiently, and the glucose, it's just left trapped out in the bloodstream.
Now, your pancreas senses that the glucose isn't entering the cells, right? So it kind of panics and frantically overcompensates, pumping out more and more insulin. This kicks off a really severe physiological cascade. That excess circulating insulin basically acts as a strict biological override command, forcing your entire body into an aggressive energy storage mode. It completely slams the brakes on utilizing energy and mandates hoarding.
And where does all this hoarded energy go? Well, it's prioritized right into visceral adipose tissue accumulation. To be clear, we're not talking about superficial fat here. This is highly biologically active tissue that tightly wraps around vital organs like your liver, pancreas, and intestines. The scientific literature is super clear on this. This specific type of tissue accumulation is firmly linked to the onset of type 2 diabetes, significant cardiac dysfunction, and even systemic issues like cognitive decline and that heavy chronic fatigue you might feel after a big meal.
Let's move on to Section 3, skeletal muscle contraction mechanics, bypassing the insulin lock.
Looking at this from an evolutionary physiology standpoint, our bodies literally weren't designed to sit perfectly still after eating a heavy carb load. In a totally sedentary postprandial state, your muscle fibers are completely compressed. They're squeezed tight, which means zero passive absorption of glucose. They are 100% relying on that faulty insulin key we just talked about. But the very moment you shift into an active contraction state, those muscle fibers physically expand. It's exactly like a dry sponge being squeezed and released underwater. They become dynamically primed for immediate glucose uptake.
And here is the crazy part, 30 to 40%. That number is the massive statistical reduction in the postprandial glucose spike observed in clinical literature when mild skeletal muscle contraction is introduced right inside that critical post-meal window. Just by altering your mechanical behavior, we can literally slash the glycemic impact of a meal by nearly half. How wild is that? Let's look at exactly how this happens in Section 4, the GLUT4 translocation mechanism, direct cellular absorption.
The biological sequence at play here is just elegantly simple. Step 1, you initiate mild muscular contraction right after eating. Step 2, that physical expansion and squeezing of the muscle fibers mechanically forces special cellular doors, which biologists call GLUT4 receptors, to rise straight to the surface of the cell. Step 3, these GLUT4 receptors activate autonomously. The physical contraction itself turns them on. And finally, step 4, glucose is sucked from the bloodstream directly into the muscle. The absolutely crucial takeaway here, this entire cellular absorption process completely, 100% bypasses insulin. The mechanical movement alone is what opens the doors.
Let's move to Section 5, Physiological Parameters of Activation, Establishing the Thresholds.
Now, you can't just do anything and expect this to work. You've really got to find the mechanical Goldilocks zone. If you go overboard with excessive exertion, like a really heavy, breathless workout right after dinner, your body panics and enters a sympathetic state. It actually diverts vital blood flow away from your digestive tract, which can trigger severe gastric distress and acid reflux. But on the flip side, insufficient contraction, like just lazily shuffling around, fails to provide the mechanical torque you need to trigger those GLUT4 receptors. What you're aiming for is a market pace, a steady, continuous, mild contraction. Think of a purposeful but totally conversational walk.
You can actually compound the metabolic efficacy of this contraction too by bringing in some secondary physiological enhancers. For example, maintaining strict nasal breathing directly activates your vagus nerve, which keeps your parasympathetic nervous system dominant to ensure proper digestion. On top of that, keeping an upright postural alignment maximizes your diaphragmatic expansion, making sure optimal oxygenation reaches those contracting skeletal muscles. These are basically your biomechanical force multipliers.
But listen, consistency is absolutely vital here. We're talking about consistent metabolic recalibration. The literature points out that this mechanism needs about 180 seconds, so just 3 minutes of continuous muscular activation. And critically, this has to happen post-ingestion across sequential daily meals. Doing it once isn't going to magically alter your baseline biology. Systemic recalibration relies entirely on chronic, daily patterns of this really brief mechanical intervention.
Finally, Section 6, Clinical Contraindications and Thresholds, Objective Safety Parameters.
Look, while mild skeletal muscle contraction is a core evolutionary function, any biological intervention comes with systemic warning signs that mean you need to stop immediately. If introducing post-meal movement triggers chest pain, an oppressive pressure radiating to your jaw, severe dizziness, cold sweats, blurred vision, abnormal respiratory difficulty, or acute unilateral pain in your abdomen or limbs, the mechanical intervention has to stop right then and there. These are critical signals of cardiovascular strain that demand professional medical evaluation.
We also absolutely have to factor in pharmacological interactions. If a patient is already using exogenous insulin or insulin secretagogues like sulfonylureas, combining those drugs with the GLUT4 pathway's insulin-independent glucose absorption creates a profound hypoglycemic risk. Your blood glucose can crash dangerously low. Also, for anyone on antihypertensives, there's a real risk of orthostatic hypotension if you stand up too quickly after a meal, not to mention neuropathic or structural joint limitations that need stabilization. Navigating these specific chemical interactions strictly requires clinical oversight.
Which brings us to a really crucial question for you to chew on, especially given the biological reality we've just unpacked. Are we systematically surrendering our metabolic autonomy to sedentary habits, precisely when our cellular mechanics demand movement the absolute most? The 15 minutes right after you consume a carbohydrate load is a defining metabolic window. By understanding the true mechanics of GLUT4 translocation, you now know that a simple 180-second physical action can fundamentally rewrite how your body processes energy. Thank you so much for joining us for today's Explainer, and we challenge you to view your postprandial biology through this strictly scientific lens from here on out.